Hi, everybody. Thank you for joining our Bright Talk session today, what we're calling Ensuring Your SD-WAN is Secure by Design. Let's see. So let me introduce myself and my colleague and our presenters today. So I'm Raul Takala. I'm the Group Senior Practice Director for WAN Solutions for NTT Limited. Based in the United States, so it's a little bit early for me, but doing okay. Gareth, why don't you introduce yourself?
Thanks, Raul. Hi, everybody. My name is Gareth Waters, and I'm the Principal Cybersecurity Go-to-Market Strategist for NTT. I've been working with NTT for 6 years, security for 12 years, and in the information technology business for 21. And it's 10 p.m. here in Melbourne, and looking forward to getting through our presentation today for everybody.
Great. Thanks, Gareth. So we've got about 15, 18 slides to take you through today. We definitely want to make this interactive, so if you wouldn't mind, if you have any questions, please put them in the chat box. We've got a colleague who's monitoring that, and we can also see him, so hopefully we'll dive in and answer your questions as they come along. Or if not, maybe we do have a little bit of time at the end, we can address them there. All right, so let's see. Hey, Gareth, why don't you take our audience through our agenda today?
Sure. So today's agenda, first we're going to discuss why choose SD-WAN, and then we're going to look at the typical SD-WAN architecture and why security must be your number one consideration. Following from there, we'll look at SD-WAN that is secure by design and understanding the key security controls. Then we move to threat modeling, SD-WAN architecture, and finally we discuss the NTT secure by design approach, and we'll finish up with the Q&A.
Cool. All right. So look, let's, before we dive into the security side of things, so I'm the WAN networking guy, and just as a little bit of context, so this isn't going to be an SD-WAN webinar. Our focus is going to be on security, but I always find it useful to at least, provide a little context. And, the first thing I like to think about is, what are the things that are driving SD-WAN just from a business perspective, right? And, really at the end of the day, I've been doing this now since before SD-WAN was a thing. I've been running our SD-WAN strategy since early 2015. And really, as things have evolved, it really comes down to, in the numerous client conversations I have had over the years, that it really comes down to some combination of these four requirements, right, that clients are looking for in their new WAN. And I'd like to start in the top right. It's really all about enabling a hybrid IT strategy as we move more and more to cloud. Cloud is fundamentally changing network traffic patterns, and to ensure good application performance, you really need to think that the traditional MPLS-based WAN just really doesn't cut it anymore, right? As you move to the bottom right, closely aligned to enabling the hybrid IT strategy comes down to, look, we have an insatiable demand for bandwidth. Gartner and several of the analysts, talk about networking requirements growing 30, 40% per annum. And, literally very few telco budgets for any enterprise are growing. And in fact, most of them are flat at best and declining in many cases, right? So the question is, how do you keep up with that demand for traffic in a very limited budget time, right? And as you move to the bottom left, what we're also looking at is, by their nature, WANs are difficult to manage, right? If you're a global organization, you're trying to manage endpoints where the majority of those endpoints have very few, if any, IT support. So how do you manage that infrastructure efficiently with oftentimes a very limited staff while still maintaining the agility that organizations need to add new services, add new capabilities to their WAN. And then finally moving to the top, and something that, just in the last year or so I've seen increased interest, because it's a new capability that SD-WAN technologies bring, is a lot more visibility into a specific application performance, right? Clients are only interested in the network to the extent that it's delivering good application performance, right? And so more and more, especially for the critical apps, wanting to have some visibility in how they're performing, so that if there is any degradation performance, that they can be remediated as quick as possible, right? And of course, all of those things are required and must be achieved in a secure manner, okay? And look, and at the end of the day, that's really, where this SD-WAN technology came from. It was, as many of you know, it was, technology that was purpose-built for this use case, to address the 4 or the 5 requirements on the previous slide. And again, this isn't necessarily an SD-WAN webinar, but just to kind of talk through it, these solutions in this space, have generally these 4 characteristics, right? A, they're starting in the top left, transport agnostic, meaning, hey, let's use a combination of MPLS plus direct internet, plus 4G, LTE, and really any combination of connectivity you can use, because really it's that transport agnosticism, if you will, that addresses the need to get the bandwidth you need at the right price point, right? Moving to the bottom left, application-based routing and steering. That speaks to the need to have good application performance where your applications may be residing really anywhere. They could be in the public cloud, a private cloud, or still even on your on-prem data center, right? So combining the ability to have multiple types of circuits and being able to route that traffic based on the application to the right traffic path based on cost and performance reasons, right? Moving to the top right, the logical way you do that is being able to implement logical virtual VPNs in a mesh or partial mesh to connect these sites over what we're calling our underlay, the transport, to facilitate and enable that sort of any-to-any routing that you might need. And then finally, the SD portion of SD-WAN, right? The central management and orchestration, that is what gives you that operational efficiency, right? So rather than having to go out and touch every endpoint, every WAN router to make any configuration change you need to do, being able to centrally define those templates and push those policies out via central controller so that you can make changes in minutes and days as opposed to weeks or months, right? So look, that's just a quick primer for where we are. So while clients' interest is very high in SD-WAN, right? Again, I mentioned to you that I've been in this seat here at NTT now for going on 4.5 years, and it's been amazing, the adoption here, how quickly it's gone from really a concept that was poo-pooed by the market to something being extraordinarily hot and moving through the Gartner hype cycle about as fast as I've seen anything move through in just a short amount of time. But the reality is there's still quite a few number of challenges, and just touch on a few of them. Starting in the top left, the market is still relatively immature and fragmented, and that's somewhat related to the lack of standards, right? There isn't a single definition of what SD-WAN is, despite the 4 characteristics I showed on that previous slide. So what that has done is it's really kind of created a fairly fragmented market where there's lots of players who are coming up and bringing to market their SD-WAN solutions. And won't go into that, but what that does do is it serves to result into some confusion, right, in terms of, well, what's the right technology, SD-WAN technology solution for me? Moving on to the top right, these new capabilities that the SD-WAN technology has brought into market is great, right? Because there's now a level of granularity and ability we can glean out of our WAN that wasn't available to us before SD-WAN came around. And that's great, right? There's a whole world of possibilities. But then when you combine that with the bottom left in terms of, that drives a new set of skills, new sets of capabilities, right? So it's kind of a, for the golfers out there, it's sort of a new swing thought, right? How do we really leverage that capability? And do we actually have the skills? Do we really fully understand what it means to kind of take advantage of these new capabilities? So, it's great. We've got a new toy at our disposal, but do we know how to use it effectively, right? And those previous four really translate into a number of sort of hidden costs that, there's one thing to do a spreadsheet exercise about how much you can save on your MPLS as you're moving to SD-WAN, and maybe some of the operational savings you're going to get because we're centrally managing it. But if you're not taking some of these things under consideration, you end up finding yourself in a situation where maybe the cost benefits aren't achieved that you thought from your original business case. So look, I could go on and on about those five areas, but really the thing we want to focus on today is the bottom right, and the one why we marked it in red in the biggest block in the bottom are the security integration challenges, right? Because really at the end of the day, while the previous five are all significant things that need to be considered when looking at an SD-WAN transformation, really at the top of the list are security concerns, right? So in order to talk about that, let's just kind of look at your typical SD-WAN architecture deployment, right? You can see, this is a fairly simplified view. I'm sure you guys that are out there running your own WANs can see a significantly more complicated version of this. But really at the end of the day, what we're looking at here are a couple things. One, you got your branch sites on the left, and on the right, you got your cloud, where your workloads are running, right? In the cloud, either in SaaS or IaaS, or even on your on-prem data center, right? And, again, very simplistic view of the logical architecture, but two things really that should jump out to you here is, one, the use of the internet for the corporate WAN traffic, and secondly, obviously, moving those workloads to the cloud. So while SD-WAN offers, significant benefits, as we addressed earlier in the presentation, a key risk is again, the use of direct internet access and cloud for your corporate WAN traffic. So maybe at this point, so I've been kind of rattling on here for a bit, maybe I could turn it over to you, Gareth, my security guru here, to take our audience here through, why is this such a big deal? Why does this really have to be the thing why is security the thing you really need to head on at the beginning of any SD-WAN consideration?
Thanks, Ralph. Sure. So look, SD-WAN is a good fit for basic edge network connectivity, but as you pointed out, what about clouds and applications that connect, government agencies, hospital systems, energy grids, public safety systems, smart cities, for whom security incidents could not only be disastrous, but even deadly. Native security in some SD-WAN solutions is based on 20-year-old designs. Without the right software and tools in place, SD-WAN is effectively going to be less secure than MPLS. For your mission-critical infrastructure and other high-value and high-risk applications, it's essential that data and the enterprise is going to be protected sufficiently, and that the SD-WAN is selected, designed, implemented, managed, and monitored correctly. But above all else, that the SD-WAN is supporting the business needs, which tend to be agility, performance, and lowering that MPLS cost, as you said earlier. So with the aforementioned challenges and due to the subject matter complexity and the range of technologies that are now software defined, securing SD-WAN is a difficult subject to simplify. But we hope through the course of this presentation that we will provide you with the insights into some of the approaches of securing SD-WAN. As highlighted here, the direct internet access is a benefit, but also one of the more prominent risks when it comes to SD-WAN, as there's the potential for a security incident due to the direct internet access breakouts. So to leverage the advantages of intelligent path selection to lower MPLS costs, you can allow DIA from the branches. But in allowing DIA, you effectively need to evolve the security stack to ensure that protection. The internet is also used as that transport for WAN traffic, which you'd expect will be encrypted, of course, with IPsec VPNs, but this is not always the case, where security is not a priority in SD-WAN technology development, where they may use unsecured GRE tunnels or L2TP, like Layer 2 tunneling protocol. So you'll see shortly the options for reducing the risk associated with DIA. So when architecting solutions for SD-WAN, there's the network requirements of determining the transport options. There's architecting your cloud edge, there's architecting your WAN edge, and then there's the evolving service layer and how to provide that right level of security and agility and application performance with a balanced total cost of ownership. In a broader sense, the outcomes really that the business need is they're looking for, you need an optimum blend of secure connectivity options to connect your hybrid IT and your clouds and your branch. You want to improve the flexibility of your WAN so it can respond to the dynamics of your cloud environment. You need visibility of those assets, data flows, security risks in your cloud-based workloads and your applications, and to be in control of traffic to applications and infrastructure, regardless of their network attributes or geographical location. There's some key considerations for securing your WAN, and more importantly, the data traversing the WAN, which include reviewing traffic policies to define which traffic is sent over which carriage type, applying controls to segment and network and secure the data in transit, and in addition, where to insert the secure network services, your firewall, IPS, WAF, content security, at appropriate points in the network in physical or virtual formats, where network function virtualization is important. And in addition to the security, in addition to the security of the infrastructure, you'll also need to consider how you'll manage your entire software-defined network, including your carriers, to improve efficiency and reduce the operational risk. So we'll come back to this diagram later, but now we'll step through the NTT reference architecture first. So here at NTT, we've defined a generic reference architecture for SD-WAN with 4 key layers. So the management layer, which deals with the operation of the SD-WAN solution and orchestration. The services layer, which is your application services layer focused on intelligent application-based functionality. We've got your security services layer. Now, essentially at its core, you should expect security in an SD-WAN solution must be, at a minimum, providing network segmentation to secure specific areas of the network, maintaining confidentiality of information, providing a capability to stop malware and perform content filtering, and preventing malicious access and attacks. Therefore, the key security considerations in SD-WAN architectures are going to be encryption and VPN, local internet offload or direct internet access, DIA, as we mentioned earlier, branch security, and network segmentation. In the software layer, we focus on areas pertaining to path selection, NFV, and quality of service and zero-touch provisioning, and the hardware layer focused on physical infrastructure. And further to these key layers of the reference architecture, let's look at the component level, baseline, and recommended controls, and then we'll walk through the security layer considerations, as well as the application of these controls. So on a page here, we have an overview of the baseline and recommended security controls for SD-WAN. This is based on our analysis of the technology, the solutions, and the threat models, which we will discuss shortly, and the risks. So as a definition, baseline controls are fundamental to the security of the solution, in this case, SD-WAN. With the baseline SD-WAN controls, we're trying to provide the best coverage for the enterprise hubs, branches, users, things, and infrastructure. And you'll see shortly how we apply the controls with different deployment models. Recommended controls, they may be applicable in certain scenarios depending upon incumbent technologies and client status. So, for example, if it's a greenfield or a brownfield, if it's a highly regulated or a lightly regulated, or there are vertical specific requirements. I'd just like to be really clear, these are not the only controls for an enterprise, as we have defined solutions for hybrid cloud, for multi-cloud, for ransomware, for workplace, etc., separately. And within those scenarios in NTT, we've defined a set of baseline and recommended controls also. So this is just merely a single solution set around the threats and risks to be addressed when considering SD-WAN. Now,
Gareth,
whilst there's nothing...
Sorry for interrupting, Gareth. Just thinking about these baseline and recommended controls. As a networking guy, I always obviously very aware of all these things. Would you mind just for a second, I know we didn't really cover this earlier, but just the difference in the baseline versus recommended. I view baseline as need to have, right? These are all ones that should be investigated and looked at for any potential gaps. And then recommended is nice to have. Is that a good way to look at it, or am I off a little bit on that?
No, absolutely, yes. That's exactly the way it is. Like, baseline is fundamental. You must be, in our view, considering and including these in your solution. And you'll see in a few moments, there are different deployment models that you may choose, but, and depending on what you may have and how you're structured, we would assess and work out with you in partnership how we will, derive what are the right set of controls and where, depending on the business drivers and the risks and the environment that we're working in.
Okay, thanks.
So, so just whilst there's nothing groundbreaking there at the component level, it's the NTT business-driven approach to the enterprise security architecture design and control selection for our clients that's our differentiator. And of course, being able to manage and detect threats through our security operations centers is a further advantage. It's the fundamental different business drivers, as I said, and the use cases that will derive the solution for you. So let's take a look at the architecture diagram again and step through the core security requirements for SD-WAN, and then we'll apply the controls on top of that. So the security elements in the reference architecture layer deal with ensuring securing of application traffic while traversing this hybrid network, as well as ensuring the individual branch sites themselves are protected against threats resulting from DIA. There were 4 key security considerations, being encryption and VPN, direct internet access, branch security, and network segmentation. So first of all, I'll step through those in a little bit more detail, and then we'll apply the controls and the different deployment models on top of this diagram as well and build it out. So the encryption and VPN. So encrypted VPNs are used to create those permanent and dynamic tunnels to secure the paths across the SD-WAN. IPsec with a form of PKI is normally used to encrypt all traffic between the source destination for both the permanent and dynamic connections. VPNs, and more typically dynamic multi-point VPNs or DMVPNs, are used as a single overlay in SD-WAN to create multi-homing and mesh connectivity between all the sites. Now, this can be implemented across any transport, making it optimal for the SD-WAN environment. The ability to automate dynamic setup of paths, as well as the marking of dual paths as active-active, contribute to simplifying operations and increasing performance. In the security layer for local internet offload or direct internet access, so over on the left you have of the diagram, you have your branches. Branches are using internet-based links to connect to the hub of the network using encrypted VPNs. They can also use these links for direct internet access, bypassing the need to go via the hub itself for internet access. This increases the available bandwidth and performance at the branch, and it lessens the requirement for larger internet links at the hub or data center. It does require the replication of security infrastructure, though, to protect against attacks. And this is due to the fact that the site is now directly exposed to the internet and its associated threats. So these can be addressed by correctly configured branch security. The third key security layer was that branch security in the reference architecture considerations. So depending on your security model, you may end up with a thin edge where more security functions are in the cloud, or a thick edge at the branch where more security functions exist at the branch. And we'll dig into that in a few minutes. And then network segmentation, which is it's not quite shown on the diagram, but network segmentation increases the security in the WAN by isolating areas of the network into logically separate zones, which are then secured from unauthorized access by users or from other zones. So this ensures that if, for example, the network edge is compromised, other areas of the network are safeguarded. A compromised segment can be quickly isolated from the broader network on these programmable networks. The zones are typically defined by functions, such as different lines of business or finance or manufacturing, for example. The ability to build different virtual networks on top of the primary network's hardware using virtualization makes the segmentation easier to accomplish. And the deployment of network function virtualization is the enabler to create, deploy, and manage these virtual zones. So network segmentation must also be used to separate the SD-WAN infrastructure adequately from the network where possible to prevent attacks, and we'll see this more and why when we look at the threat modeling. So with those 4 key security considerations, there's also a multitude of deployment models. So let's look now at the deployment models. So when we look at the SD-WAN architecture, what we start to see is a number of deployment models with the same network application security requirements across them, but can be delivered with different approaches. The following models show common deployment scenarios and can be used to guide the approach to securing a client's SD-WAN. Now note the legend, and that wall symbol indicates security functions and not a firewall in this instance. And we just need to be clear, a firewall or a next-gen firewall alone is not adequate security for SD-WAN, and you'll see why as we progress. So in the deployment models, the SD-WAN fabric is used to connect the branch sites to the internal applications and services typically hosted in the data centers or in the public IaaS instances. And for this, SD-WAN vendor options exist to filter traffic between sites if required by policy. For external access to the web, SaaS applications, and public cloud IaaS instances, 3 main deployment models have been defined around security features required for the implementation of security controls. There are numerous other deployment models, let's just be clear, that we have created, but we found is that we can cover most scenarios and implementations in these 3 models for demonstration purposes. So deployment model 1 on the left is a centralized security model. All the branch traffic is routed via the SD-WAN fabric via the selected underlay path, and the security controls are implemented at a regional hub or a central site like the main data center, for example. So whilst this is the legacy approach to securing the enterprise, this is a potential deployment model that could be maintained post-moving to an SD-WAN solution. As with any SD-WAN solution, there's 3 main trade-offs being absolute security, application performance and business agility, and total cost of ownership. In deployment model 1, you get absolute security with the trade-off being the impact to maximizing that application performance as you're backhauling all your traffic. And the total cost of ownership kind of remains stable following that legacy trajectory. In deployment model 2 in the middle, we've got the decentralized security model where the local internet breakout is used for web and SaaS. So when a branch has direct access to the internet, this security layer needs to be replicated in some form at each branch with this kind of access in order to protect the branch and the broader enterprise from security threats. This can be achieved with what might be referred to as a thick edge with a set of physical or virtual controls at the branch. The pros to this model is that you take advantage of that application performance and business agility that you want. The cons being that threats from the direct internet access, which must be addressed with more dispersed security. And another con would be that increased total cost of ownership, because now you've got a dispersed security stack, an operational model. Deployment number 3 is on the right. It's the centralized security model for web and SaaS traffic, like the deployment model 1, but the security controls are implemented by cloud-based services. So also known as SASE, or Secure Access Service Edge, for delivering network security functions like firewall as a service, DNS, threat prevention, DLP, secure web gateway, and CASB, and more. SASE it's a new term in the market for what Gartner defines as the future of network security, where we see the convergence of network as a service and security as a service layers. So the pros for the centralized security stack is that it provides the advanced security requirements in a consumable model, and it also allows the business to take advantage of the agility to execute quickly on their digital transformation plans without being held back by physical technical debt from legacy security stacks. The cons we find are deployment model 3 requires network, security, cloud, and dev teams to work closely together to achieve faster outcomes. In both deployment models 1 and 2, security controls can be deployed via service insertion and chaining features from the controller. And for the public cloud and IaaS connectivity, deployment models 2 and 3 are decentralized models where we also see SD-WAN extended to the IaaS instance. This requires additional security functionality to be included in the public cloud deployment for the implementation of security controls for the WAN traffic. Clearly, there's an option to have the IaaS connected directly to the cloud security service. We've just tried to simplify to the most common initial deployment models for this presentation. So now we move on to the putting it all together. So here we have another view of the Secure by Design SD-WAN solution with all 3 deployment models and the baseline security controls. What we're not showing here yet are the supporting consulting, implementation, or managed services. Again, so deployment model 1, blue in the bottom center, classical network design, all the internet traffic backhauled across the WAN to a regional hub or primary data center. Typically see your large next-gen firewall, IPS and web proxy as the center of at the central site for implementation of security controls, as well as to provide that network segmentation and protect the SD-WAN infrastructure, including out-of-band interfaces, which we'll discuss shortly in the threat modeling section. This is still a valid design and could be selected for compliance reasons where it's not possible to deploy all of the required security controls at the branch or in the cloud. In this deployment model, public cloud IS instances normally connect to the data center only, either via IPsec tunnel or direct connect or express route or whatever your cloud service is. This means that the data center security stack can be used for all the IS traffic and none needed in the public cloud end of the connection. Patch management of the SD-WAN infrastructure is a critical component to maintain pace with reported infrastructure vulnerabilities, and we'll see and discuss why in a few moments. DNS security is used to protect sessions before the connection, as well as to monitor data exfiltration within DNS. Encrypted traffic analysis and SSL inspection is critical as such high percentage of malware uses encrypted connections. And CASB can be used for the protection of SaaS applications and can be implemented fully in the cloud as API-based control or in combination with on-prem inline capabilities with secure web gateways. So CASB allows for visibility and policy enforcement for SaaS applications that you can't always get with an appliance. CASB also allows control to database policies. And then finally, in the deployment model 1, we've got messaging and email security to protect the organization, being a requirement due to the proliferation of threats via email. So for deployment model 2, we have direct internet access from the branch sites over on the left. We see internet traffic, either SaaS, web, or both, being routed out at the local internet breakout at the branch. Path optimization features can be used to automatically select the best path to SaaS applications, which would be either via the local path or another site. Security controls are implemented on the branch SD-WAN edge device itself via integrated features or on a virtual network function if the selected device supports network function virtualization. A separate physical firewall is also an option. The edge device or devices are often referred to as thick edge when this is done, due to the physical hardware requirements needed to support this model. This model tries to replicate the same security controls at the branch as we had at the centralized site in deployment model 1. This is not always possible though, due to complexity and cost. However, what we do end up seeing is reduced traffic at the hub site internet breakout and therefore lower spec hardware requirements over time potentially there. And again, as discussed in the overview, we also see SD-WAN extended to the IS instance, so all the IS traffic from the branch doesn't get routed by the hub sites. As before, patch management is critical. Remote browser isolation can be used to prevent malicious code entering the enterprise network by ensuring web sessions are executed in the cloud provider and none of that malicious code gets in. And network malware sandboxing or malware sandboxing provided from anywhere within the network or the cloud will ensure files being downloaded from the web are tested to ensure that they do not have malicious payloads. Finally, deployment model 3, the cloud-based. So cloud-based security functions are used for web and SaaS traffic. This traffic is tunneled from the branch to a SASE provider via IPsec tunnel, typically deployed via the SD-WAN controller, or it can be provided as individual services as well from the cloud. The edge device needed for this requires a lot of less resources and functionality and is often referred to as the thin edge device. It's still the perimeter of the network separating it from the internet, so it needs to be a hardened device with some level of firewall functionality in it. Cloud-based SaaS platforms with integrated services offer a powerful solution that will continue to mature over time. SASE always offers protection for users, also offers protection for users when off the network. And this solution can be deployed for guest internet only as an option too. Again, patch management is critical for the edge devices, but it's generally maintained by the vendor in the cloud, orchestrated SD-WAN solutions.
Wow, Gareth, that was a load of information, comprehensive view of the security controls that really really illustrates everything that needs to be evaluated as part of any SD-WAN design. I mean, it's not just about the routing and whatnot, right, that I hit on at the beginning. I can almost really look at this as the what, why, and how, and where of the related security controls. So thank you very much for that. And I'm sure you could even go into much greater detail into each of the deployment options. But tell me, don't enterprise organizations also have to take into account the overall security of the SD-WAN infrastructure itself? I mean, after all, if a threat actor hacks into the management or control layer up here at the top of the SD-WAN infrastructure itself, the enterprise is at risk of losing control over its entire WAN, is it not?
Yeah, that's right. Yeah, definitely. So, there's a number of security pain points when it comes to SD-WAN and some of these assumptions that must be discussed and addressed. So, the assumption that SD-WAN technology itself is secure is effectively false. SD-WAN hardware, it's built from a combination of commercial off-the-shelf software and or open source software. So there's the potential for security vulnerabilities in all software, and numerous SD-WAN vulnerabilities have been found and reported. Protecting that SD-WAN hardware is as important as protecting the data and the assets of the organization, and it can lead to access to all the networks and the data. In a moment, I'll show you through basic threat modeling where these vulnerabilities and logical design vulnerabilities expose weaknesses in the infrastructure, and that must be considered. The other one is that the equipment has sufficient built-in security as well. So SD-WAN equipment, it's built to process packets at high speeds, and a number of partner technologies do have security functionality built in, which is dependent on risk analysis, may be acceptable for the use case. There's a step up into an approved level security where the technologies have that network function virtualization technologies. And then the SD-WAN implementations by and large, though, are never as full-featured as a dedicated security appliance that performs SSL inspection, has threat detection, and custom chips, that are geared towards processing these packets and doing security functionality. So our secure SD-WAN architecture ensures a more holistic security-focused approach, which considers options such as the direct internet access, the threats from the cloud and the branch, and this is aligned to Entity Secure by Design integrated solutions approach.
So on that, Gareth, so how does NTT Security Division, kind of what's the way we look at to make sure we're taking into account all the risks when it comes to SD-WAN infrastructure?
Yeah, so our NTT digital forensics and incident response engagements tell us that attackers are spending a long time within customer networks. They're mapping out and accessing the network and IT infrastructure. They're building resilience, command and control, ensuring persistence with lateral movement, and using privilege escalation before executing on the mission. You'll see now as we look at the threat modeling why all this is relevant as SD-WAN is pivotal to network access. So as well as the reference architecture components, we've illustrated here a basic SD-WAN logical architecture and the flows between the orchestration plane, the management, control, and data planes. Given the complexity of the SD-WAN reference and logical architecture, it's easy for a security professional at least to see that there's the potential for vulnerabilities to exist in all levels of this architecture that can be exploited. So threat actors, may exploit weaknesses in, for example, let's go from the bottom up, the data plane. So you've got outdated operating systems here. You've got Ubuntu, Debian, and CentOS. That's what these, edge devices and custom devices are built on. There's a potential for exploiting those operating systems at this layer if left unpatched. There's a lot of known vulnerabilities in the, the NVD, in the vulnerability database, and there's potential zero-day vulnerabilities in this large and commonly used operating systems. Also in the data plane, you've got out-of-band management and baseboard management controllers, so your OOB interfaces effectively. Weaknesses in the architecture protecting the out-of-band access and weaknesses in design of out-of-band software can lead to easy exploitation and persistence as well in the network that can last through a rebuild of a device. So you can wipe and reload a device, but if the attacker is sitting in the firmware, the out-of-band management, which is completely separate and not on the hard drive, an attacker can have persistence in your network. So then up in the control plane, you've got your network element packet processors. So in the control plane layer, in the software-defined network, you've got your processing, routing, BGP, OSPF, overlay tunnels using unsecured GRE, MPLS, and then your VPNs, and they're susceptible to cryptographic threats as well. Also, what's a peculiarity in this particular layer is that the control plane, the orchestration, and the management layer tend to be connected in the back end, and sometimes with a SQL database. So a vulnerability in SQL or a SQL injection vulnerability in any of those areas can allow an attacker into your controller and therefore start to move up into the device and thus into the network. I could go on about the threats in the management plane. You've got the CLI, SSH, and Web UI. Again, despite all best practices and security guides, they recommend don't connect these to the internet, the management interfaces. But by design, sometimes they're used to communicate with system administrators and also with other SD-WAN components like the orchestrator and controller for zero-touch provisioning. So they have to be open to the internet, and that just opens up your attack plane. So there's many other threats that can be exploited throughout all of these layers. The final, one of the bigger ones is the cryptographic layer, and cryptographic mechanisms must be employed correctly to secure on all planes, data control, management, and orchestration. Cryptographic mechanisms are the essence of SD-WAN, and in crypto it's known as a couple of informal rules. The first rule is don't develop your own crypto, and the second one is don't implement well-known crypto primitives. Unfortunately, the current state of practical SD-WAN products adds a new rule, like don't provision your own crypto, because it's been found some SD-WAN products, fortunately not all, have flaws relating to provisioning, using hard-coded public key pairs and corresponding certs that are the same for all customers that can't be replaced, self-signed certs, manual installation self-signed certs with no chance to revoke them, etc., etc. So by exploiting vulnerabilities and weaknesses in the SD-WAN infrastructure through the nature of its design and supply chain, attackers may have easy access to your entire network. We've mentioned a lack of standards earlier, and it's for this reason that the solutions for SD-WAN do not conform to a common approach, and that in itself breeds potential for further complexity. Effectively, the lack of standards is a breeding ground for insecurity. So in creating the reference architecture deployment models, we've considered the threats to all the elements of SD-WAN solutions and derived those reference architectures that address the key requirements. It's important to choose the right solution for your business needs, and entity consulting, advisory, and technical consulting services are well positioned to define the strategy, assess the risk, and help to choose the right technology fit through assessments to meet your requirements. So let's look at the key requirements through the NTT approach and the potential solutions. So what we've seen is based on the threat model and the typical deployment models, you need a mature SD-WAN strategy aligned to your business and cyber strategy. You need the right technology partner to develop an integrated approach to SD-WAN and security for your enterprise. You need a method to secure the infrastructure, to secure the branch, and to secure the user. And all of this must be achieved while enabling the business to be agile, reducing costs, and continuing to provide that application performance and benefits of SD-WAN. Now, I've mentioned secure by design at NTT, and we believe in a connected future that is secure by design to help business minimize their risk while they continue to innovate and grow through digital transformation. That's effectively our why. So what we mean by secure by design is cybersecurity can no longer be an afterthought. We've all seen the impact that a successful cyber attack can have on a business. The damage to brand reputation, trust, and profitability can take years to repair. Secure by design means by being cybersecurity conscious at all levels of the business. This involves security as a key tenet of an organization's overall business strategy, a security strategy that's aligned to what the business wants to achieve, as well as the business's risk tolerance, and an intelligence-driven cybersecurity posture that enables business to be agile in the face of changing threat landscape and technology ecosystem, and building in security rather than bolting on to digital programs, whether it be for your infrastructure, network data center or clouds, your workplace, your employees, your buildings, your customers, your customer experiences, or your business transformation initiatives such as IoT and blockchain and application security.
So how do we, that's quite a mouthful. I mean, look, at the end of the day, I think everyone gets now, all the controls, the threat modeling you went through. How do we go about, helping our clients, enable this, secure by design concept?
Yep. So with our access to global threat intelligence, we help our clients to predict, detect, and respond to cyber threats while supporting the business innovation and helping them manage risk. So intelligent cybersecurity is about helping organizations understand where and when the threats will strike and help businesses to take necessary steps to protect themselves and minimize their risk. In cybersecurity, intelligence helps the business understand if an attack on a business has already occurred and the impact, as well as what attacks are being planned, by who and when they'll occur and why. It can also help use to educate and inform and evaluate whether the business has an adequate security posture and what's the business risk level. So moreover, it should be evidence-based and actionable to help the business take the necessary steps to protect itself, applying those tools and processes and technologies and controls to maintain an appropriate security posture for maximum security. So our recommended secure by design approach is to start with the cybersecurity advisory consulting. Here you're going to help you understand your current risk profile and chart your future security strategy. This allows us to determine that as is and to be states, which is also benchmarked against peers in best practice. Because it's modular, we can help the clients build a roadmap in the areas that are particular focus, such as SD-WAN, by completing the CA for digital infrastructure, which evaluates your security capabilities for all aspects of physical and virtual networking and computing, so your organization is able to manage the risks from countless entry points into your environment and from potentially insecure devices and applications. Based on what you need and where you want to go, we can select and align and design the right security architecture you need to achieve your goals. Our pedigree as a global systems integrator ensures that we can deliver any number of integrated network and security solutions. We provide global support from our partners' technologies, all our partners' technologies, through our global delivery centers. And when you partner with NTT, our implementation, technical support services, and managed security services are geared towards continuous optimization, a partnership, and ensuring a security posture over a long-term basis. So we have a suite of managed security services depending on the solution and the controls. The threat detection service is our primary SOC service focused on advanced threat detection through machine learning combined with our analyst expertise. The enterprise security monitoring service allows for monitoring against regulatory compliance, business policy, and best practice requirements. The NTT Security Device Management Service allows for operational management of your security infrastructure, allowing your team to focus on high-value tasks. And the Vulnerability Management Service provides the ability to scan and manage vulnerabilities in your environment. So, with that, I think we're getting to our last slide and 2 minutes to go, Raul. So why choose NTT for cybersecurity? So we're focused on your business outcomes. Through partnering with us, we can help you create an intelligence-driven security posture. We're able to guide our clients through the entire journey into a digital infrastructure world in a highly secure fashion. We have 2,000 security experts across the globe to work with the thousands of certified global network professionals across the full life cycle of network and security services, and we have 4,000 clients across every vertical. In our 9 security operations centers, more than 9.5 terabytes of security data is analyzed every day to help you find the needle in the haystack, with our advanced threat detection analysis is 99% accurate. And we've invested more than $100 million in cybersecurity R&D and innovation, and all of this is brought together in our secure by design approach with our consulting, technology, and managed security services. So, Raul, any further comments from you from the...
Yeah, look, I think, you know, again, very comprehensive view of security considerations, you know, look, that's exactly what we were meant to do here today. We hope you guys found this informative. Sorry we didn't leave in a little bit more time for questions. We'll try to get to those and send those out to the audience after the event. Thank you very much, and we'll hope to talk to you guys in the future.
Thank you, everybody.